Matter is an important part of chemistry, and we learned it in the definition of chemistry. Chemistry is the study of matter and its transformations. One of the things that a good science does is it classifies knowledge. For instance, in biology, you have the kingdom and classes of the animals, living things. In chemistry, matter can be classified very easily. The classification scheme is as I have shown here on the board and should be studied. We talk about matter, and matter exists in three states: solid, liquid, and gas, which you're familiar with. If you look at matter, it's either pure or it's a mixture. What I'm asking you to do is to observe all around you. Everything you see and touch and feel is matter. And try to decide if this is pure matter or a mixture. If it's pure matter, it's either going to be an element or a compound. Some examples I have to show you is these substances. This is potassium chromate, nice yellow color. It's a solid, crystalline solid, and it is a compound. This is copper sulfate. Again, it's a very nice blue crystals, and it is a solid. We have some things classified as metals, and these are elements. You may recognize this kind of this color, copper. This is copper metal. Metal has a property that is kind of shiny. You may recognize this. It's a liquid metal. The only liquid metal we have is mercury. And then this is two different kinds of metals. There's lead shot mixed with iron shot. So two metals. So as we look around this, we have elements and metals, and we have compounds, pure substances, both elements and compounds. Another classification is mixtures. Now, mixtures can be homogeneous or heterogeneous. Homogeneous means it's the same throughout. For instance, a solution. Here is a solution of sodium chloride, salt solution. It's clear, it's the same throughout in every way. Here is a mixture of lead shot and iron shot. And it's not homogeneous because I can pick out different particles throughout. It's heterogeneous. Things like gravel, sand, they're heterogeneous mixtures. One of the things that you might be interested in is that what chemists very often try to do is they try to separate mixtures into their individual components. And this can be a pretty complicated process or simple. One simple way would be to start with this. This is a heterogeneous mixture, lead shot and iron shot. Iron has the property that it's attracted to a magnet. Lead is not. And so I'm going to be able to move this magnet over there, and as I move it along, it's going to collect the iron, and you'll see there's the lead shot, here's the iron shot. I've separated this heterogeneous mixture with the use of a magnet. So if you want to separate mixtures, you just have to do some kind of physical process to do that. One interesting mixture that I very often give the students to separate is a substance like this. This jar contains about 35% ammonium chloride, 35% sodium chloride, and 28% silicon dioxide, which is sand. So this has sand and salt in it. So I have to think of a property which would be a difference between them. And one of the things I'm going to do, I'm going to take my mortar and pestle and pour some of this mixture in here and kind of grind it up so that it's pretty even, pretty well mixed. So it's pretty homogeneous, but yet it can be separated, because one of the things about the separation is that you have to use some kind of properties. Let me pour some of this mixture in here, and let's put some water in it. Now we do know one little thing, and that is that water will dissolve the sodium chloride, the salt. And so as I shake this around, add in some water, distilled water, stir it up. Some part of it is dissolving, but not all. We know the sand will not dissolve in water. And so what we can do here then is we can, the ammonium chloride and sodium chloride dissolved, and the sand is kind of stuck to the bottom. And so I can use a process called filtration. It's kind of a big word, but let me move forward here. I had set up a little filtration apparatus, and basically all I have to do is quickly pour this mixture in there and probably rinse a little bit that's stuck in the bottom. Now what you will see is that what is coming through the filter is clear. It contains sodium chloride and ammonium chloride, and it is separated out in the filter paper is the sand. So filtration is a very good way to separate some kinds of mixtures. Another important process for separating mixtures would be distillation. Well, let's look at this distillation apparatus we have set up. What we have is a solution of water and a colored substance, potassium permanganate. And what I'm doing here is I'm boiling the solution. Now, when a substance boils, it's the water that's turning to a vapor state, but the other substance, the potassium permanganate, is staying in the solution. And as the the steam rises, it goes through a condenser. This condenser is cooled by a cold water jacket, and as it condenses, you'll see a drop come out of the other end of this. And so what we have over there is the clear, no longer pink because it's only the water, and as it condenses, so I'm separating the water from the solution from the potassium permanganate. So distillation is a way to separate solutions back into their solid, whatever was dissolved in them, and their plain solvent, the water. So it's interesting to see that this apparatus has the colored solution, and as it boils away, only the water comes over and the other part remains. So separation by distillation is another method of that. So let's look again at the idea of classification of matter. Matter is classified as either a pure substance, and that pure substance will be an element, and we'll learn about those later, or a compound, a definite composition. You cannot separate a compound by a physical process like distillation or filtration. Or it will be a mixture, and we can work to try to separate mixtures either by distillation, particularly of homogeneous solutions, but we also consider air as a mixture. Air is a mixture of gases, and we have seen before you can take air and cool it down and get liquid oxygen, liquid nitrogen from it. So it can be separated by the opposite of distillation, cooling down, or you can see alloys, which are also mixtures, homogeneous. For instance, brass would be a mixture of two metals. Finally, the heterogeneous mixtures can be something so much as a Hershey bar with almonds in it. Parts of it are different, or an emulsion, oil and vinegar. So classification molecules, I encourage you to look around and try to imagine what substances are made of. Imagine, say, the aluminum on the edge of the blackboard here. That is an element. So we're dealing with chemical substances, and we're dealing with classifying what they are. Are they elements, compounds, pure substances? Are they a mixture? And can the mixture then be separated then into pure substances? That's the work of chemistry.